guys, welcome to Unit 5. Unit 5 is all about energy, how we can control energy, measure it, and manipulate it. So we're actually need to figure out what energy actually is. So you'll need your notes, your pen and paper for this. We'll go through what energy is, the first law of thermodynamics, and different types of energy. So energy is just the capacity to do work. It's the ability to move something. So if we take a look at this wind turbine, and we see these wind turbines all along the North Country, we can see that with the wind power actually helps rotate the blades, and that helps to manipulate or make changes within the gearbox, and that generates power for us. Of course, there's so much more to it. In fact, wind energy is such a great new field, and we do have a lot of that going on up here in the North Country. So let's take a look at the first law of thermodynamics. It's called the conservation of energy. So it states that energy cannot be created nor destroyed, only transferred between system and the surroundings. So that's the big formal definition for it. Pretty much if we look on the bottom right, we see the cue ball for a pool table. If we push the cue ball, that pushes the red ball right into the pocket. If we take a look on the left-hand side, my least favorite thing, ice, we see that when ice melts, the heat from our hands helps to melt the ice, so the heat was transferred from our hands to the ice, and then therefore the ice will melt. Again, a little bit more to it, but that's just the basics for it. So let's talk about the different types of energy. We can break them down into potential energy, which is what we call stored energy, and kinetic energy. So energy that's not stored, we pretty much call it energy of movement. So let's take a look at potential energy. Actually, between the two, we can actually transfer energy between the two, between potential and kinetic energy. So for potential energy, the main thing that we'll look at here for chemistry are bonds, chemical bonds. So if we take a look here, this is adenosine triphosphate. We saw this back in bio. We know this as ATP. And when we actually break the bonds between the phosphates, or between those P's, we actually need to absorb energy. The bond will absorb energy in order to do so. We will have also taken a look at nuclear power, the potential energy stored within all of those nuclides. We've seen electric potential energy. And in physics, you'll see gravitational and elastic energy. For kinetic energy, we'll take a look at thermal energy, and we've seen that. We know that temperature is a measure of average kinetic energy, and we'll also talk about heat and how heat and temperature are different. We've seen light energy, so when we've exposed certain chemicals to a flame, we know that they produce a colored light. So when the electrons go to the excited state, they have to absorb energy. When they go back down to the ground state, they release energy in the form of light. We've also seen electric energy. So there's two types of electric energy, potential and kinetic, and we'll kind of go through what those are. You'll see sound energy in physics, as well as potentially wind energy in there. So the major types of energy that we'll talk about are chemical energy, aka bond energy. So this is the energy that's stored in bonds. Back in bio, we used to say that if breaking bond releases energy. That's not really true. It's not the whole thing. When we in order to break a bond, it requires energy because there's so much so much attraction between the two molecules in a bond that we actually have to add energy to it. So if we take a look at the adenosine triphosphate, or the ATP, pretend the hammer is something that's going to break this bond. It's requiring energy in order to take off that last little phosphate. When we form bonds, that releases energy. Again, a little different than what you've seen in bio, but go with it here. So if we take a look at the bottom right-hand side, we see three different molecules, one of which is water. So if we take a look at the bond between the hydrogen and the oxygen, we see that there's 111,000 calories per mole of energy per the O and the H bond. If we take a look at the carbon dioxide, there's 192,000 calories per mole of the C double bonded to the O. And there's 82,900 calories between the two carbons, and 98,700 calories between the carbon and the hydrogen. So each different type of bond has a different amount of energy in them. And of course, we need that same amount of energy in order to break those bonds. We also take a look at thermal energy, or heat. We need to make sure we realize that this is not temperature. Make sure you highlight that, make that big and bold. Temperature is a measure of average kinetic energy. Heat is actually transfer of energy. So we measure it in calories, joules, or kilojoules. Enthalpy, which stands for H, or has the symbol H, is the transfer of heat. And this is big. We're going to be seeing this all throughout this unit. If the change in enthalpy is positive, we call that endothermic, meaning energy is being absorbed by a system. If the change in change in enthalpy is negative, it's exothermic, and that means energy is being released by a system. We also talk about different types of heat transfer: conduction, convection, and radiation, which you can see here on the bottom right, and thermal equilibrium, that conservation of energy between one system and the surroundings, as we've seen right here with the ice in our hand. Again, the heat from our hand transfers to the ice, which helps melt it. So to summarize, energy is the capacity to do work, and work is being able to have something move. We have a conservation of energy. That's our first law of thermodynamics. Chemical energy, aka bond energy, is huge. That's one of the biggest things that we'll cover in this unit, as well as heat, which is the transfer of energy. Let me know if you guys have any questions. Take care. Bye.